Hello, this is Roberto and this is the HVAC is my channel. Today we're going to be talking about how to size a furnace based on manual S. Pretty much this is a practice problem, alright? Alright, let's get into it. To begin with, we're going to start with the heat load calculation. So the heating load in this case is going to be the following. So we have this heating load, 34,949 BTUs per hour, and as we explained in the previous videos, this is based on a manual J calculation using Soft, or you can also use Elite or different other programs. All right, so now on the previous video we were checking the furnace or the air handler was a good man. So now we're utilizing another manufacturer. This is going to be American Standard. Okay, so you can always choose, you can always work with Carrier, American Standard, York, Goodman, Train. There are different manufacturers. That depends on the contractor or also whatever the homeowner is more comfortable with, okay? But mainly the contractor gives you that recommendation. All right, so once you have the heat load calculation, you have the model, see? This is the model of the furnace, then you can see if this furnace is going to comply with manual S heating sizing protocols. All right, so let's do a small recapping here. So for manual S, there we go. For manual S, based on ACA standards, ACA, all right. So it says for heating, this is just to remember, your overheating or oversizing factor, overheating percentage, all right, overheating percentage has to be within the range of 100% to 140%. Okay, that's my optimum efficiency. All right, but what happens if you don't have enough CFM? And also today we're going to mention the CFM. Then you can go up to 200 just to match the CFM. You jump to the next size. All right. So optimally, so in a perfect world, you would like to be in this range. But personally, I like staying 110 to 140. All right. 100 is for me kind of risky a little bit, but that's what the manual says. Manual S says 100 and 140 and up to 200 depending on the CFM. Okay, so based on this, what we remember is the overheating is going to be equal to the capacity divided by the load. Okay, so in this case, since we're talking about heating, that's going to be the heating load. But when we say about the capacity, that's the output capacity, not the input. So now let's calculate the capacity. Capacity, okay, let's do that calculation. Capacity. All right. For the capacity, what we need is the model number. So what is our model? The model is actually American Standard, and it says AUD 1B080 and then A9H31AA, and every manufacturer will have their own nomenclature. For example, in this case, what we're going to have is the following. So in this case, so what is A? A and U means an upflow and downflow. So these two codes means upflow and downflow. But after you find the nomenclature, what is more important is to find the AFUE, which is 80%, and also the input. So in this case, what we have is based on the nomenclature. See, I'm just gonna double check on that. So A and U means upflow and horizontal. The furnace can be positioned upflow or horizontal. D is 80% induced draft. So 80% induced draft. This is AFUE. And again, you can always double check the nomenclature online. You can go to Google and PDF, and then you can find what is the nomenclature on American Standard. Okay. Now, one is single stage. So this is one single stage, and then we have B, and B is cabinet size. So B is cabinet size, and the cabinet size is actually the width of the furnace. So in this case, B represents cabinet B, which is equal to 17.5 inches wide. Okay, and then 80 is actually the capacity. See, this is capacity. And how do I know this? I'm just checking on the specifications and the nomenclature of the manufacturer, which is American Standard in this case. All right, so based on that, we're going to calculate the capacity. So the capacity is going to be equal to 80K. So this is 80K, right? 80 means 80K. So 80,000 BTUs per hour. But also, this is the input capacity, right? So we need to find the output. So the output would be multiplied times the AFUE. And the AFUE is 80%. So the capacity is going to be equal to the following. We're going to have in here 80, this is 80 times 0.80. Okay, 80%. So the output capacity is going to be 64,000 BTUs per hour. There we go. All right, so let's just put this into green. Whatever we get from the manufacturer is actually the, let's see here, input. This is the AFUE, okay, and this is the output. See, output. For overheating calculations or for sizing an equipment, we always need the output capacity. The manufacturer and the model number always gives us the input, and we multiply that times the AFUE, which is the percentage. This is an 80% the efficiency of the furnace. All right, so the reason I put capacity is I don't want to complicate this formula, because I don't want to put output capacity, heating load, cooling load. It's just capacity divided by load, but this is heating load, this is output capacity. All right, so now let's go see what's the load. We already have the load is that. Okay, so what's the overheating? Overheating is going to be equal then to 64,000, which is the capacity, output, right? Divided by the load, 14,949. And then if we want to express this in terms of percentage, if it's percentage times 100, so what's the overheating percentage? That's going to be equal to the following. So it's going to be 64,000 divided by 34,949, and that's going to be 183. There we go, 183%. All right, overheating. Does that comply with manual S? Yes, it does, because it's below 200. Is it optimum? It's not optimum, because optimum would be supposedly 100 to 140%. But personally, I wouldn't go 101, 102. 110 to 140 would be for my house, the one that I would love. But now, this was for a furnace that was 80K. This is for an 80,000 BTUs per hour furnace, 80K. What happens if we do it for a 60K? Just out of curiosity, what if it's a 60K furnace? Okay, 60K furnace with the same AFUE, 80% AFUE. What would be the manual S output? Like, does it comply with manual S? Would it be better to have a 60K furnace or an 80K furnace? Let's be curious about it. So what would be the capacity in this case? The capacity is going to be 60,000, okay, 60,000 times AFUE 0.80. So the capacity in this case, it is capacity equals to the following. So that's going to be 60,000, 1, 2, 3 times 0.80, 48,000 BTUs per hour. That's the output capacity, 48,000 1000 BTUs per hour. Okay, this is BTUs hour. The load is the same, so the overheating percentage is going to be 48,000, which is the output capacity, divided by the load. Since we're having a little bit of space in here, what we're gonna do is just do the other side, which is better. Okay, divided by the load, which is 34,949. So the overheating is going to be equal, overheating percentage, let's do the calculation. That's going to be 48,000 divided by 34,949. So that's going to be equal to 137. So this is 137% furnace. Okay. And this is based on a 60K furnace. All right. Now the installer or the designer has the option to decide which furnace he's interested in. So if it was my house, if I was installing this furnace and I want the best for the customer, we always want the best for the customer. So personally, I would choose option number 2, which is 60K furnace instead of option number 1. See? Both are going to work. In fact, option number 1 is going to work even, I would say, better and quicker. But if we want to be more efficient, energy efficient, 137% is excellent because, see, manual S is saying that you have to be within 100 to 140. So 137 for me is perfect and more than enough for sizing the equipment. And also, you're going to save more money to the customer because this is a bigger unit that is not necessary. It's going to do the job, but it's not going to be necessary. It's not necessary to have a bigger unit. So you can always choose the smaller unit that is going to do the same job, save energy, and also it complies with manual S. All right? Well, I hope you enjoyed the... Oh, and also, let me also mention that what happens if you choose 60K furnace, but however, this 60K furnace is only giving you the maximum CFM, let's put this in pink actually. What happens if the CFM that this furnace gives me is 900 CFM? It's just coming from my mind, 900 CFM. But they say that the house actually needs 1200 CFM. So in that case, this complies with the heat and load, but however, it's not enough because the house requires this CFM, for example. So in that case, when the house requires this CFM and the option 2 doesn't provide enough CFM, this is in high speed, it doesn't provide enough CFM, then yes, you go to the next size, and in the next size, that's where it says up to 200% if necessary to comply with the required CFM, all right? All right, I hope you enjoyed this video, and in the next videos, we're going to be talking about heating CFM and cooling CFM, all right? Share and subscribe, and hit the like button. Thank you.